Hi guys, welcome to Math Today. Today we're going to be doing pages 5 through 7 in the quadratic graphing packet. That packet started with Introduction to Quadratic Functions, Common Core Algebra 1 that you should have already watched a video on. That was pages 1 through 4. Now we're on page 5 and we're going to be using the graphing calculator. So if you don't have it, maybe you want to pause and go get that. Okay, so we're going to be using the graphs of quadratic equations. And remember, a quadratic equation is generally written in the standard form. And this is not going to be equal to 0. This is going to be equal to y because we're looking for it to be a function. It could also be equal to f of x. Okay, solutions for quadratic equations can be found by graphing and finding the x-intercepts. The x-intercepts are also known as the roots or the solutions. It's going to be where the parabola, which is the name of the graph of the function. All quadratic functions, when they're graphed, they're called parabolas. And we're going to be looking for the roots. So when we're looking for the roots, there are three things that could happen. The first thing that could happen is what normally happens is that it intersects the x-axis twice, and we get two roots. The next thing that could happen is it could be what's called tangent to the x-axis, which means it touches it in one point. And that would be one solution or considered two equal solutions. And then what could happen is it doesn't touch at all. It stays above it. That means there are 0 real solutions. So a solution is not real. It's called imaginary. When a solution is not real, it's called imaginary. So remember, we have the real number system that is rational and irrational. Imaginary is not part of that. It's not real. Okay, so to graph this, what I'm looking for is what I would call some critical points. And you don't have to have a lot of points. I would say at least 5 points. And you can get those 5 points from your calculator, or you can get them by doing substitution. One of the things that I'll often do is what's called the axis of symmetry formula. It's x is equal to negative b over 2a. And I do that so that I can find the x coordinate of the vertex. And I always like to have that as my middle number on my chart, because you'll notice that there's symmetry about that point. So if I do x is equal to negative b over 2a, the negative of negative 4 is 4, and 4 divided by 2 is 2, so x equals 2, which means I'm going to use 2 as my middle number. Okay, and you can use your graphing calculator. So what you would do is you would just go to your y equals, and you would type in the equation. So the y equals is already there, and you do x squared, subtract 4x. Be careful, don't use the negative sign because it's not the same, and then subtract 5. You can hit second graph, which is table, and I want to copy the points that are around 2. So if you look at 2 comma negative 9, that's the vertex or the turning point, and then you want to get some points around it. You don't need to take consecutive points, but you want to get points that are around it. So 2 is negative 9, 1 is negative 8, 0 is negative 5, negative 1 is 0, and that gives me 3, 4, 5. Okay, so 3 would match with negative 8, 4 would match with 0, and negative 1, 4 would match with 0, and 5 would match with negative 1. Okay, I'm also going to grab negative 2 comma 7, because then it'll help me make a nice picture. And it's really more about just making a picture that looks symmetrical. So I always like to have the vertex and then points on opposite sides of it. And I decided to go for just one more up here so that it gives me a nice look. And that's it. That's my parabola. It's nonlinear, so you kind of want to be smooth when you're connecting it. And there's a bunch of things that you can find out from this. The lowest point or the minimum point is called the vertex. The roots or the zeros are there. And then if you drew an imaginary line down x equals 2, that would be the axis of symmetry. Okay, next page. All right, so example 2. All right, so again, you want to put that in your graphing calculator. And you want to get some critical points. I'm going to use -5, 9. I'm going to use -4, 4, -3, 1, -2, 0, -1, 1, 0, 4, and 1, 9. Okay, so -5, 9. -4, 4, -3, 1, -2, 0, -1, 1, 0, 4, and 1, 9. Here we go. Okay, so this is a great example of something that has only one root or two equal roots. Okay, so things that you could look for would be the domain. The domain would be all real numbers. The range. So if you know it comes down and then goes back up, so it goes down to 0. It includes 0, so we could say y is greater than or equal to 0. Okay? This point here on the bottom is called a minimum. It's also called the vertex. It also happens to be the root or the solution. Okay? So this is what the graph of a parabola looks like. And you can use your graphing calculator to always double check it. You can also use substitution. Example 3 you're going to do on your own. So you do this one by yourself. I'm going to go through example 4 with you. Okay, so example 4. Okay, again, you can use this formula, x equals -b over 2a. And it's x is equal to -4 over 2 times 1. So x equals -2. And that gives you the axis of symmetry. That's the imaginary line that divides the parabola in half. So think of the parabola as 2 parts, okay? I personally always put that as my middle number on my chart. And you can get the y value from substitution, or you can use your graphing calculator. So one more time on the graphing calculator, you would hit y equals, and you would type it in. So x squared plus, whoops, I made a little mistake there. Let me go back. That should be where the plus is, and that should be where the 4 is. What is going on? Let me just clear this out. One of those days. Okay, so x squared plus 4x, come on, plus 3. And here's what the graph looks like. You'll see that it has the 2 roots, it has the vertex, and we would put arrows on that. Okay, you can also hit second graph and look at your table. And you'll notice the symmetry around the turning point. Here's the turning point, -2, -1, and there's symmetry around it. Pretty cool. Okay, so I have -2, -1. I have -5, 8. I have -4, 3. I have -3, 0. And then all its partners. Okay, so here we go, graphing. 8, -4, 3, -3, 0, -2, 1. Dun, dun. Okay, there we go. So now here's some sample questions that you would have to answer. The vertex, what is that? And that's an ordered pair. So notice those are parentheses. Don't get that confused with interval notation. End behavior, it's increasing. That means like both arrows are going up. Okay, the y-intercept is 3 because it crosses the y-axis at 3. The x-intercepts, and that's in these kind of things, they're called braces. It intersects the x-axis at -3 and -1. Remember, you can have 2 roots, 1 root, or no roots. No roots is called imaginary. And then average rate of change, that's just slope using those x numbers. So -2 belongs with -1, and 2 belongs with 15, and then I just do slope. So y2 minus y1 over x2 minus x1. So that's 16 over 4, which equals 4. So what that's saying is that if I went back to my picture and I connected it, and whoops, come back. If I made a line, so say this is my picture just so you can see it in front of you. If I made a line that connects when x is -2 to when x is 2, that line or line segment would have a slope of 4. And that's really all they're asking about, average rate of change. Okay, so now you're going to do page 8, this example 5 by yourself. Have a great day. Keep safe. Wash your hands. Talk to you soon.